Hey, what's up everyone? Welcome back to my channel. This is part 5 of my beginner's guide to selling Tesla puts. And I will cover these things. If you haven't seen my other videos, check those out first. Today I'm going to go over implied volatility. And here's my little table of contents for this video. First, I want to give a quick disclaimer. I'm going to cover what implied volatility is, how it's measured, and then how it's used, and then also a couple other metrics that use implied volatility that make it a little bit more usable to make decisions, or to based on context really. So my disclaimer is this: I think selling options or buying options or whatever can look super confusing, and it actually is super confusing in terms of all the different math that goes behind it. But I think it's unnecessarily confusing. So if you're trying to sell puts, I don't think you need to really understand every single thing to a very high level. Especially for me, I'm not a day trader. So I'm not making tens or hundreds of trades a month, and mine are more directional. So these metrics aren't as important to me, if that makes sense. I had actually bought this book called Options, Volatility, and Pricing, and I read it I tried to read it, and then it's just like super dry, and I just kind of gave up. So I don't think you need to be that technical to make money. So just want to throw that out there. But I think it does help to at least know what's out there. So just know what you don't know, right? So my goal in this video will be for you to just at least understand, hey, what are people using and what's out there? Because I think that's pretty half the battle. If you kind of have an idea of what you don't know, then it makes it a lot easier. Plus, I see applied volatility all the time on like Wall Street's bets, so it's helpful to know what it is. Not to say that you should be looking at Wall Street bets. Okay, anyway, so implied volatility. What it is, it's a measurement of how much the stock is expected to change in the future, right? So this is not looking in the past. This is looking in the future. Okay, so this is how volatile the stock will be in the future, right? And how this affects puts is that the higher the implied volatility, the higher the option prices will be. And the lower the volatility, the lower the option prices will be, right? Because if everyone thinks that the stock price is very volatile, then they're willing to pay more for a put that's farther out of the money, right? Because there's a higher chance of it happening, right? So imagine if you think that there's a higher chance of you getting in a car accident, then you're going to be willing to pay more for your car insurance, right? And that's why I like to sell Tesla puts, because that means the premiums are very high, because it has a very high implied volatility. So what implied volatility? Oh, so one really important thing about implied volatility, just to remember, is that it is derived from the option prices, not the other way around. Okay, so the prices don't come from the implied volatility, but implied volatility comes from the prices, and the prices come from a market, right? People are buying and selling these puts, and it has the price, and then they use that price, they put in some formula, and then they give you this implied volatility number. Okay, and what that implied volatility number represents, it represents one standard deviation above and below stock price over the course of a year, right? So what does that mean? That means that if you take implied volatility, you multiply it by the stock price, that range plus or minus the stock price plus or minus will determine 68%, right? So if you remember stats, AP stats, this is the bell curve, and the first standard deviation is always going to be 34% above, 34% below the average, right? So 68% probability of it being here. So what does that mean? That means that imagine if the stock price was $100 and your implied volatility is 10%, then there's a 68% chance that the stock price will be between $90 and $110 this year, within 1 year. Okay, and just another example: if the stock price is $100, implied volatility was 50%, that means there's a 68% chance that the stock price will be between 50 and 150 in 1 year. Okay, I'm imagining you can multiply that in your head and see how I got these numbers. But if you can't, it's basically 100 times 50, you get $50. You subtract it from 100, you get 50, and you add it to 100, you get 150. Okay. So why is this useful to you, right? So let's graph it out. So here's my graph. Imagine I still have my stock price $100. My IV was 50%. That means one standard deviation below will be 50. One standard deviation above is 150. So this green area is going to be 68%. All right. What this also means is that if it's under 50, there's a 16% chance that it will be under 50, right? And why is this useful to me? Because when you're selling puts, you're trying to pick a strike price that is below whatever the stock price will be whenever it expires, right? So you could use the standard deviation to say, okay, if I pick 50, then there's basically an 84% chance that it's going to finish out of the money, but a 16% chance they'll finish in the money, right? So that's a pretty good, probability. Maybe I feel okay selling it at 50 by using this IV that I calculated, right? Hope that makes sense. So basically, your IV can help you determine what strike price you feel comfortable at. And this is why if there's a higher IV, people are willing to pay more, because you have such a wider range, okay? Okay, so how do you calculate if it's less than a year? So this formula that I gave you earlier, it only calculates for a year. So basically what you're doing, you're taking the stock price, which is 100, multiplied by implied volatility, which is 50% times 100, right? That's kind of like plus or minus. That's what we used before. But what if I'm selling a put that's 30 days out or 60 days out, right? Obviously, then that number needs to change. And how you do that is multiply it by the number of days over 365 and take the square root of that. And that's how you calculate it for a shorter number of days. And I'm just going to brush through this because I don't think you actually need to do this ever. But just so you know how it works, that's how the math works. Here you can see my option chain, right? I have an implied, this is my Tesla option chain. I can see there's implied volatility. And you can see Tesla has a very high IV rank. So if I really wanted to, what I could do is I could say, okay, I'm going to take the current stock price, $1,088. I'm going to multiply it by 62%, for example. And then I'm going to multiply that by the square root of 16 over 365. And I'm going to get a number. I'm going to add and subtract it to 1088. And then those will be my standard deviations. And then if I wanted to sell a put that was going to be 16% chance of it being in the money, 84% chance of it being out of the money, then I would use that number to sell the put. I would pick that strike price, right? What you could also do, most brokerages have like other things. So there's a probability calculator. You can just plug that number in. So today, for example, I sold a put for March 18th at 975, and if I use the one standard deviation, I use like the whatever this is, the volatility for 90 days, then I can see that the probability of me finishing in the money is 40%. Right, which is not great. But when I sold it, price wasn't that low. So not a great trade that I did, but there's programs you can use to do it, so you don't really need to know how to do the math. But it's good to know how you get there. So if I give you that number by itself, I give you 62% by itself, it's not super useful. Well, it is useful in calculating the standard deviations, but it's not useful in understanding whether that's high or low, right? So another metric that they have is called implied volatility rank. And really what they do is they basically take the current rank, so let's say 60% minus the year low, and then they divide that over the year high minus the year low. So essentially, if you're at the year high, it would be basically 1 over 1. It'd be 100%, right? If you have like the year low, it'd be 0 over some number. It would be 0%. So if it's 0%, that means it's the lowest it's ever been. If it's at 100%, it's the highest it's ever been. If it's at 50%, it's in the middle of what it's ever been. Okay, so that's IV rank. So that's helpful to know how you're doing in comparison to how the IV has been over the past year. This kind of takes your high and low, so it doesn't really take your frequency. So there's another metric they use is IV rank percentile, and this is more frequency based. So for example, if you have like one day that's super low, that's not as it can kind of throw it off, right? So this is more of like how you rank up compared to the rest of the days in the year. And the thing about that is kind of your PSAT score, you get like, oh, I tested 99 percentile. That means you're the top of the top out of 100. So if it's a 99 percentile, then you're the top out of 100 percent. Versus like if you're at 50%, you're in the middle of based on frequency, not based on the values. So that's a good summary about implied volatility. Hope you found it helpful. Yeah, so next time you see implied volatility somewhere, you'll at least have an idea of what it is, right? I personally don't think it's super important. That's because I don't day trade, so that's probably why. Other people might disagree, but at least now you have an idea what it is. If you have found this helpful, please like and subscribe, and we'll see you in the next one. Thank you.